My name is Ray. I'm a developer advocate for the Google Cloud Platform. And there are two things I really like to do. Number one is to bring some of the latest and greatest technology that Google has to offer to developers all over the world. And the second thing I like to do is, of course, to hear about your experiences and your feedback on our technology and also on about Google Cloud Platform. So if you have any questions, any comments, any feedback, please contact me on Twitter @Saturnism. Okay. So RPC, how many people here have heard about RPC before? Yeah, quite a few. How many people tried to use it in the past? So I think the world has kind of moved on to something else like REST, right, with JSON over HTTP. I think that's what many people are using for their APIs today. And I think that's also really, really good, especially on the public APIs. But RPC has been around for a very long time. How many people here actually remember the days of using Corba? Yeah, DCOM, RMI, yeah. SOAP is not really RPC, but there's an RPC flavor of it. So I found this website the other day. This is pretty funny because, let me click on it first. I found this website, let me show you. Because I was trying to remember how to do Corba, and, and there's a tutorial still online from 2013. And of course, you start out with like a Java project. This is a Java-oriented talk. Then you kind of define, this is Corba, by the way, you need to define like an IDL. This is nice because most of the RPC framework require this so that you can generate the stubs for different languages, for different platforms. So you define it in yet another language, right? And then you can generate multiple stubs from there. And then here is what you do with Corba. You use the IDL, you create the stubs with a utility. And it generates a bunch of Java classes or any of the files for you. And then here's where it gets me, almost there. And then you implement the stub by in this case, the addition operation. And then here is what gets me. This is how you start a server. I have no idea what this is doing, to be honest, not anymore. But you have narrowed the object first, and then you create a reference. I mean, oh my goodness, you create a name component, and blah, blah, blah. And then that's just how you create a server. And then you try to use it. It's not any easier. There's just a lot of code involved, right? But I think that's why RPC had a bad experience, a bad connotation in the past. And then people used RMI for Java developers, and that's really easy to use. But at the same time, it was not very interoperable. And so in the end, there was a revolution with SOA, with SOAP, with WSDOs and XML. Again, they have bad connotations for different reasons, but at least it was interoperable. And people very soon figured out RPC at the time was not the right way to think about a solution. And then they kind of move forward towards the document format. And that later lead to resources and then REST, right? But RPC is still very, very good, especially when you are dealing with, say, microservices. If you are creating your systems with microservices or breaking down your backends into multiple components, then the first question that you're going to have is, well, you gotta manage this new component, right? We have other tools to do that. But another problem you're going to run into very quickly is how do you communicate between the two, okay? And is it efficient enough for your backend services to use that type of communication? In most cases, in a small system, I think that's, any type of communication mechanism is going to work pretty well. But as you scale out, you might run into issues. So why RPC? Well, mostly RPC is going to be a binary-based protocol so that it's going to be even more efficient than a JSON payload over HTTP. And in most cases, they are going to be strongly typed. Remember, in JSON format, these are just JSON objects, but you need additional, potentially, again, languages to describe what the endpoint looks like, and how do you describe what the payload should look like. And there are many different formats for that, for JSON. For example, I think one of the most popular one is Swagger. And from there, then you can generate potentially a strongly typed object for you to consume. But then there are some operations that is just not easily expressible in REST. because REST uses the HTTP protocol, but it also uses the verbs that HTTP protocol has to offer. So there's the get, the put, the delete, and the post, and the patch. But if you have to do anything more complicated, more sophisticated than just a simple CRUD operation on the resources, if you stick with REST, you would find yourself in a situation where you're trying to play with the verbs, but also playing with the URL and also the parameters in order for that to work. So for example, if you are trying to complete a complicated transaction as far as, say, restoring money from a bank account of some sort, it will be a little bit more difficult to express in a RESTful manner. And so rather than doing that with RPC, you can actually describe, again, the business object and the business operation you want to use, rather than being limited by the CRUD operations. And I think RPC, as we saw previously, it was a little bit more complicated than it should be. And it would be great if RPC is simple and interoperable. Okay. So at Google, we do all of our backends with the RPC communication. We use our internal tool, internal framework called Stubby. And it is a binary protocol, and it is very efficient. And this is something that I didn't know about before, mainly because we don't usually talk about it. But at Google, we can have up to 10 to the 10, okay, RPC calls per second. That is a significant amount of RPC calls that we are making in the backend. Now imagine if you're using something less efficient, it just take one byte more. That is 10 to the 10 more bytes per second that we have to transfer, okay? And so we made Stubby so that we can do this as efficiently as possible. And later, very recently, Google, and in conjunction with Square, I believe, we actually open sourced this internal technology. We took it to the next level. So based on Stubby, based on the experiences of creating Stubby, Google and Square, we took it to the next level, and we open sourced this new project called gRPC. Now, maybe people may think gRPC, the G in this must mean Google, but it's not. It's actually a recursive acronym. gRPC means gRPC Remote Procedural Call Framework. Okay, it's recursive. And it's really simple to use. It's performant, it's scalable, of course, and it's interoperable. And how do we achieve that? Well, first of all, there's still an IDL, so you can create your service definition with the IDL language so that you can generate multiple language stubs. It's using protobuffer 3, which is, again, a serialization framework. It's a binary serialization framework where rather than serializing into text, we serialize into a compacted binary so that you can transfer the payload efficiently. And it's also using HTTP2, which is also a binary protocol as well. And it has other nice things, which I'll go into in a second. But with gRPC, there in the initial blog that they posted, they did a very quick comparison, basically with the same amount of data, how fast can you achieve the throughput and such. And this is just a high-level comparison between gRPC throughput, which can go up to, say, 120 megabyte per second, but with the same type of data, the same type of application with HTTP and JSON, of course, is a little slower because of the size of the payload is much, much bigger, and you have to spend a lot more time to serialize and deserialize JSON. And if you think about this, this is what we said about SOAP many years ago. It was too slow, and it's kind of like coming back around and saying that in some cases, especially in your internal backend, JSON over HTTP could also be slow than what you might wish that you have. The other thing that's really interesting is that per CPU performance is, of course, also significantly better when you're dealing with a binary payload. So here is per CPU throughput on gRPC in this specific test was about 30 megabytes per second, and JSON was magnitude slower in this case. And this is important. This is important because that if you are moving into, say, a cloud-native solution where you do want to be able to, say, run your application in the cloud or have a hybrid situation where you have on-prem and the cloud and burst into the cloud, you want to reduce the amount of resources you consume, right? Because that is the amount of money that you're going to pay. You're going to pay per CPU and memory. So as a cloud provider, I'm going to tell you that, yes, use less if you can, right? Use as little as possible because that's actually what's going to cost you the money. So in this case, you can have more throughput with less CPUs. That means you have to use less resources, which is good for you. It supports multiple languages, but I want you to pay attention to 3 of them, especially Objective-C, C#, and Java. And these are important because these are also used in mobile devices. gRPC are made with mobile first in mind. So the mobile devices, your mobile applications, can also use the gRPC protocol to talk to your servers. And there are multiple advantages to that. Number 1, you're going to use less bandwidth. And because of that, you're also potentially going to get better latency, faster latency in this case, so that you get your responses faster on the mobile devices for your users. And second to that is that you might actually be using less battery on the phone as well. And last point I want to make before I jump into the demo is HTTP2. How many people here has seen HTTP2 in action already? Has heard about it? Heard about HTTP2? Quite a few. So that is the new protocol. gRPC uses HTTP2 behind the scenes, and it offers 2 things I want to mention here. It offers a lot more, but just a couple of things I want to mention. First of all, it's binary. Okay, rather than saying get / with like 5 bytes, you say there's a header, there's a binary, like there's one code just for get, so that you don't have to send the entire verb over. You just send like a byte or like a bit over. But it's also multiplexing the connection. So rather than opening up multiple connections to the same server to request multiple different objects, it can actually multiplex all the requests together, multiple streams together in a single connection. Okay, so you kind of get rid of the overhead for TCP connections. But also, it can do streaming. It can actually do server-side streaming, so you can push data from the server to the client over the HTTP2 protocol without any kind of special hacks or anything like that. Just built-in as a first-class citizen. And you can also do client-side streaming, and you can do bidirectional streaming over the HTTP2 protocol, which is really nice. Just to show you the speed of the difference, the feel of it, there's a little website here. I promise it's the only time I'm going to use your hotspot. Okay, so it's downloading HTTP1 over the hotspot, by the way, this gentleman here. And it took a certain number of seconds. And let me see if HTTP2 is, yeah, that's a little bit faster. Did you see that? Let me go back to here, comparison. They are downloading the same images. By the way, this big image is just composed of multiple tiles. So it's going to make multiple requests in HTTP1 and just a single connection in HTTP2. Let me just do this one more time. Let me do a refresh. And there's no cache header here, right? So nothing is being cached. And then, boom. Yeah, amazing, isn't it? So gRPC is using HTTP2 protocol to do all sorts of communication as well. So let me just show you how this is done. How many people here are Java developers? All right, so Java is going to be okay. So I'm going to show you a few Java sample code here. Most of it I need to still create. I still need to write my sample code. So with gRPC, the first thing that you need to do, oh, I cannot see it. The first thing you need to do is to create the IDL, right? It's the interface definition language. And for gRPC, we're using protobuffer 3. So we're using the proto definition language here. So we have to create a proto file. And in this proto file, by default, it's going to interpret it as a protobuffer 2 syntax, which is not what we want to use for gRPC. So the first thing we need to do is to say syntax is equal to proto3. Okay? And then you can send in multiple options. And these type of options are actually being used by the compiler, the generator, which is going to read and parse the proto file and create the actual stuff for you. You can actually give it certain options to take. So for example, for Java, I can say Java multiple files equal to true. Otherwise, it's going to create a single giant file with all the classes in the same class file. I don't like that, so I want it to be spread out, to be one class per file. Then I need to set this option. And then I can go ahead and define the message, the payload that I want to use. Okay? And this is probably one of the most important part. You need to define the request and the response that the gRPC service will be able to take and to return. And to do that, I can just do message. And then I can say, give it a type, like string, and then name. And here's the important part. I need to give the messenger a name as well. Hello request, like that. And then I can give it the attribute or the fields, pretty straightforward. Can you guys all see that? I'm gonna make it a little bigger, yeah. And then here's the important part, the tag. This is the numerical value that will be turned into a byte or multiple bytes, depending on how big the value is. And this value is going to be used in the binary payload to indicate what field it matches to. So like in JSON, you're going to be using this entire thing as the value, as the key, right? And you're spending 4 bytes or 5 bytes just to mark it. And then if you have like 10,000 messages, that's 4 times 10,000 messages just to do that. So in gRPC, because it's binary, we just use numerical value to indicate the field. And the other thing you can actually do is, let me just go ahead and define the response as well, right? So I can do response, and I can say string greeting is equal to 1. Once you set the tag to a numerical value, you don't really want to change it. If you change it, it's gonna be a little messed up, because that is the indication for the field. If you change it, it will be mapping your data to the wrong field. So you don't wanna change it afterwards. Like once you set it, it's done. It should be there until you decide to deprecate it, and there are different ways to do that. Okay, and there are actually more structure you can put into it. So for example, if you need to use a list, if you need to say, I need a list of something, you can just say repeated, say hobbies, repeated string, hobbies is equal to 2. I can do that. That's really easy. I can also use a map. Like in Java, map is strongly typed. In gRPC, in Proto 3, it's also strongly typed. So you can have the key type and the value type. Okay, so I have a bag of tricks. One of them is not live coding. That's not my bag of tricks. And I need to set it with the tag as well. And you can also do enumerations. In Java, there's enum. In Proto 3, there's also enum. So you can also do enum. Sentiment, for example, how good you are feeling right now. I'm feeling pretty happy, so I'm gonna say happy is equal to 0. Unfortunately, you might be feeling a little sleepy. I hope that's not the case. I'm gonna say sleepy is equal to 1. And by the end of this talk, you're going to be extremely angry at me. So I'm going to have another one, angry. and then so I can just use this enum, say sentiment, and set it to 4. And that's it. That's really what you are doing, defining the types. And later we'll generate the classes just based on this. And finally, I can go ahead and use these payloads, the request and the response payload, and create a service. So I can call this a greeting service. And to define the operations I can perform on this service, I can define multiple of them. I'm just going to do one right now. I'm going to say RPC, greeting, and then the request, and it returns response. And that's it. That's all it takes. Okay, and you can have multiple ones here. Just one catch here is that it can only take one of each, like one argument for the request and one argument for the response at this moment. Okay, and then what do? Because we're all Java developers, I know you love Maven. How many people use Maven? I just want to see you show off. Yeah, that's right. I picked the right technology. Grado, of course. It works for both. We have plugins for both. And for Maven and Grado, you can just go to the gRPC website here. This is the GitHub site. And you can just find whether you want to use Grado or Maven. Grado is apparently more condensed. And Maven is obviously a little bit different. So I'm going to copy and paste this because I cannot live code this. You'll be here forever. All right, so now that's it, and now I'm ready to compile this IDL. And what I can do then is I can go back to this server. I'm going to make sure I'm not cheating, so I'm going to do a clean, and then I'm going to do a package. Oh my God, what's going on here? Response is not defined, so I did something. Oh, of course, this thing right here. So, yeah, hello response. There we go. Yeah, type safe. I like type safety. Oh no, there's another one. What is this? Sentiment, illegal start of expression, failed to execute, illegal. What is going on here? Enum, sentiment. Did I not do this? Okay, so let me just get rid of it for now. What's that? Oh yeah, there you go. I have a note there. Yes, you do need to define the package. Yeah, so we can define the package for your gRPC payloads as well in the service. That's very good. And then I can say calm-down-example.server, whatever. Yeah, there we go. Okay, so we can do that too. Let me try that again. View success. There we go. All right. So what happened then is the target. We actually generate all of these sources for you for the total buffer stuff and the gRPC stubs as well. So everything is just generated for you behind the scenes. So let's go ahead and implement this. It's pretty straightforward, hopefully. So I'm going to create a new Java class, say a greeting service implementation. No, I do not want this in Git for now. And if I pick up my source, I should be able to say greeting service. Yeah, there we go. And I can just go ahead and implement it. Okay, now here's the trick. Here's the thing that you have to remember when you use gRPC for Java. At the moment, for example, what we created was a simple unary operation. Unary meaning it takes one request and it sends one response. It is not streaming anything. It's just one request, one response. In Java, most of the cases, you may be thinking, wait a second, shouldn't the stub look like something else? For example, like hello response, greeting, and you take hello request into the request. Like that would be what you would think about when you're doing this in Java directly. But the generated stub looks a lot different, doesn't it? It's slightly different. That is because on the server side, it tries to implement everything asynchronously by default. Because whether the consumer, the client, wants to make a synchronous call or an asynchronous call is purely dependent on the client. Okay? It's not the server's decision to make. And so by default, it's going to ask you to implement all the services asynchronously. And it's also good because it can potentially be more scalable as well. We will make the decision of whether to make this call asynchronously or synchronously when we get to the client side. Okay? So we get the request, so I can extract, for example, the name from the request. So I can say request.getName. And then I can construct the response. I can say hello response. And in gRPC, in Proto 3, all the generated code for you uses builders. Okay? Some people like it, some people don't. But the more you use it, you just get used to it. But how many people here like to use builders? I want to see a show of hand. Yeah. And how many people don't? They prefer new constructors? Yeah. All right. So here we're using builders. It's a hello response, new builder, and then you can set the greetings, and you can say hello and the name. And then what I can do is to send it back to the client. Now, remember, there's no return statement here because we're not sending it back synchronously. We're also not using future here. It's just a callback. So the callback is the response observer. And you just say on next. And you can just return the value. And of course, I have to assign this response. Oh, sorry. Let me response. And you have to, here's the thing, you have to build it. I don't understood it. Okay, so here's the response, and that's it. Another thing that's very important you gotta remember is if you think this is done, it is not. The client will not stop listening for your response until you say, I'm done, which is you gotta call uncompleted, okay? And that is the catch here because it is asynchronous. Now, here's another catch. You can actually make multiple unnext calls if you want to. You can code this multiple times, and no one is going to tell you no until you run it. Until you run the server, you are starting to make multiple responses. It's going to throw a runtime exception and telling you, no, you cannot do that. Okay, so just remember, if you can only take one response, you gotta make this kind of call just once. And that's it. That's pretty simple. And then you need to start the server. So I need to go back to that core block code with this long, very complicated thing to start. No, I'm just kidding. To start a server is also very easy. You can just say, let me blow this up. You can say server, builder, which port you want to listen on, port 8080. And you just add the service you want to register to the server. So I can say something like greeting service gRPC dot bind the service and the new greeting implementation I just did, and I'm going to build it, okay? And that's it. And once I have this server object, I can do that, and then we just do server start, right? A lot easier than what we have to do in the past, I think, okay? And then I think I need to wait for termination, otherwise this thread will just quit because the server is running in the background, and this whole process will just die, so I have to wait for it. And that's pretty much it. So if I'm lucky, I'm going to run this server again. Oh, I hope it works. It's actually working. I'm just kidding. It's actually working because I'm not printing any startup statement here. So this server is running, and we can actually go ahead and use it. Okay. Pretty easy and straightforward. And to consume it, I'm just going to show you how to consume it as well before I show you a little example of streaming. To consume it, this is what you do. In gRPC, you have to create a channel from the client side to consume the service. Now, a channel is really just a higher level abstraction of connections. So we don't want you to having to deal with the actual TCP connections or the HTTP connections, right? If you need to do load balancing, if you need to do connection pooling, you don't have to deal with it. It's all encapsulated behind the scenes with channels. So first of all, you're gonna create a channel. So you can say manage the channel. Channel is equal to manage channel builder, because everything here uses builder. So we're gonna use the builder. And I can say what server do I wanna connect to. So I'm going to say, in this case, localhost and port 8080. And then I can say, this is important, at least for this demo. I'm going to say, I need to use plain text because I don't have any SSL or certificate set up. That's, of course, that is more difficult to do in Java. But just for the demo, I'm going to say use plain text, okay? And you can set a few other really interesting options here. For example, you can set executors for you're actually executing the client's stuff, and also for the connection stuff. But more importantly, I think it's here, the load balancer and the name resolver. This is important because I don't know if anyone here uses something like a Spring or Spring Boot or Spring Cloud, or you guys use like some kind of registry to register your services so you can understand where all the endpoints are. If you're using any of those things, then you probably want to have an implementation of name resolver where you can resolve like a logical name to multiple, potentially a set of endpoints that you can connect to. And then you can use the load balancer to determine the load balancing strategy across those actual endpoints. So you can implement your round-robin load balancer, you can do something else. It's all up to you. Okay, but before, if you set any of those, it's pretty easy to do. If you have more questions, I can show you an example later. So once you have this channel, then you're ready to use it. You just have to build it, and then you're done. And to get to the stub, remember, everything was generated for you. So the stub is actually generated for you as well. So the client stub, you can do something like greeting service gRPC dot new stub. And notice here, we have 3 different stubs. There's the one by default that is the asynchronous stub, and then we have the blocking stub, and then we also have another asynchronous stub that actually uses features. Okay, so if you don't want to deal with callback on the client side, you want to deal with features, you can also use a feature stub. And the return value is just the feature of the type that you're returning. And for this example, we're just going to do a blocking stub, and you just pass in the channel here. And let me assign it to something, to stop, and that's it. And now you can make the code. So you can say code greeting, the hello request, builder, set name, right, Ray, and then set add a hobby, for example, photography. That's what I like to do. And in the end, you build it. Okay, and that's it. That's all you have to do to make a call. And this is the response, and I should just be able to print it. Print line response. Oh, sorry, system out. No, print line response, and that should be it. Okay. How many people think this will work? the first time? Oh, thanks, guys. Thank you, thank you, thank you. So, nobody raise their hand, just so you know if you're watching the video. So let's see. So I'm going to run this, compile it. There we go. You see that? Yeah, thank you, thank you. No, that was too easy. That was too easy. That was too easy because it's just one simple request. It's a hello request. I'm going to do something. I got like 10 minutes. I don't know if I can finish on time. I'm going to do something else here. I'll show you a little bit about how to implement with streaming. And remember, you can do bidirectional streaming. And that is really cool because then you can create something like a chat server or chat application, something that requires real-time communication between the two. Now, the traditional way of doing it, of course, is with potentially WebSocket and whatever, like your own TCP connections. And you can take care of this with gRPC as well. So I'm going to show you something like this. Okay, so I already wrote it because I don't want to write this from scratch again, but you can see that there's a payload because you understand this already. I have the service, the RPC code. The only thing different here is that I am annotating it with stream before. Okay, so what that means is rather than returning just one thing, now I can return multiple things, and it will be streamed to the client side. And if you think about being reactive, right, this is really it. When I stream something to the client has a listener, then you can update the UI in response to the incoming messages. Okay, and here's the problem. We need to implement it because I don't have it done yet. But here's the thing. The reason I want to implement it because for Java developers to wrap your head around the stub that was created for you takes a little time. Why? Because you are getting a stream of data from the client side as the request, and you're responding a stream of data as the response. But look at this. Look at this RPC stub carefully. What you're returning is actually an observer that captures the incoming data. What you are receiving in the parameters in the argument is actually the callback that you want to use to return the data to the client. So it's reversed. If you haven't seen this already, it's reversed. Okay? So that's one thing you just really need to remember. And it took me a little time to get used to it, but it's really nice after you internalize it. So for example, I need to listen to all the incoming requests. And for me to do that, I need to use a string observer. So I can say return a new string observer. And this is the observer that's going to be listening to the messages that's coming in to the server. So I can do something like system out dot println and value. I'm getting nervous for this demo because it usually doesn't work. All right. And once you receive it, I want to send it to all the other observers that's from the client that's also listening to the new messages. And so to do that, I have already registered the observer into a list of observers, and I can iterate over it. And I can say observer dot on next, for example, and I'm going to say this is a chat message from the server, new builder, set message, the value, and build. Okay? And that's it. That's all I need to do to send all the messages from one client to all of the servers. Yep. And then what I'm going to do, if you receive any errors, I want to propagate it. So I can say response observer dot on arrow, for example, and everybody gets the arrow. And when it's complete, I'm just not going to do anything. Oh, and maybe I need to unregister it. So I'm going to say observer dot remove my response observer. Okay. Basically, if there's anything that's bad that's happening, I want to deregister the client from my list of observers. Okay. So this is a very, very simple single server chat server, and that's it. That is it. I'm returning a streaming observer that listens to the incoming data from the client, and I'm calling the observers to send data back to the client. Okay. Now, I hope this works because I only have 5 minutes. So I'm gonna go ahead and run it. Come on. Okay. Good sign. It is running right now. So I'm gonna do one more thing. So I'm going to go ahead and implement the client. Okay, so the client is here. It's Javafx. Anyone use Javafx? No? First time? A few. Anyone use Swing? AWT? No? We're all web developer here, I suppose. Okay, so this Javafx is pretty straightforward. I'm gonna make this fairly quickly. Basically, I have the stub. You see the stub already, right? You have the stub, and this is an asynchronous stub. So what I'm going to do is I'm going to call chat service dot chat and a new stream observer. Why? Because this observer, from the client's perspective, is what the server is sending to me. And whenever I receive something, I want to add it to the list, the UI. And the way I do that in Javafx is I gotta do a platform dot run later, and then I'm going to run it in a thread. Okay. And what I can do then is, for example, I can, and if you're using Android or whatever, you use different ways of doing this. And I'm going to just go ahead and say messages dot add the value dot get message dot get from, and let me just do one thing here dot value dot get message dot get message. Okay, and that's it. That's all I need to do to listen for the incoming responses from the server and then print it to the screen somewhere. If there's error, incomplete, I don't care about this right now. Now here's the other thing I need to do. How do I send data to the server? How do I do that? I use another stream observer, okay? So remember, this stub will return me the stream observer that the server is listening to. And so here, I can get that reference, and this reference is what I can use to send data to the server. So I can say observer.onNext. And if I send a chat message over, that's going to be sent to the server. And so for me to do this, I need to make a, when you click on like a little send button, I need to do that. So I'm going to say send, set on action. Here's the action. Okay. And then I need to make this call. So I'm going to say observer.onNext. Okay, almost done. Chat message.new builder. Yeah, you're getting used to this already, right? And I can set it to from. And I think there's a name field, so I'm going to say name.getText. Oh, I used the wrong one. Yeah, I'll change it. And then I have the message, and then I'm going to get message.getText. And I'm going to build it. Okay? And of course, this is not on arrows, this is on next. Okay, there we go. Everything compiled? Again, one more time, how many people think this will work? More people think this will work. Thank you, but I don't think it will. I got 2 minutes. Oh my God, not bad. It's a good thing. All right, Ray, hello. Ah, nice. It is not bad. Wait. So I'm getting it from the server, but that's too easy. I'm going to start another client so that we can have a real chat here with myself. Gilliam is here. Gilliam is speaking next. But unfortunately, I do not know how to spell his name. I really don't know. I'm sorry. I got your name wrong. Now, let's see if that works. And it shows some of both. Yeah. So that is gRPC. It's really, really simple and easy to use. And give it a try. You can run this in many different platforms with whatever language that you like. So thank you very much for your time. Thank you.